So let us discuss about how to find out the location inaccuracies with the help of a problem. So a fixture is designed to machine a radial slot on the component. On loading the component onto the fixture, all of its 6 degrees of freedom have to be arrested before commencing the machining operation. Calculate the location accuracies of the fixture. So the necessary dimensions are already shown in this figure. Now this is the component, this is the fixture. A location fit of 150 H7 is chosen between the spigot of the component and the recess of the fixture, and a hole, datum hole, is drilled to a size of 15 H8 at a PCD of 110. This hole is located with a position tolerance of 0.05 with respect to the datum A and B. So the PCD axis is coinciding with the axis of this spigot. So now this is the positional tolerance assigned to the location of this datum hole. On the fixture, we have to drill a hole for the purpose of fitting this pin. The smaller diameter of the pin will get assembled with this hole on the fixture. So between this diameter of the fixture and this diameter of the pin, we have to choose an interference fit. So it is chosen, this diameter is chosen as 8 with a tolerance of H7. This diameter is dia 8P6. So similar to the component, the hole on the fixture has to be drilled at a PCD of 110 with a location accuracy of 0.02. On the datum pin, there are 2 steps. So there can be out of coaxiality between the axis of the bigger end and the smaller end. So to control the eccentricity between the 2 diameter, a position tolerance is assigned. A position tolerance of 0.005 is assigned to the bottom end, taking the axis of the top end as the datum. The pin diameter is taken as dia P. A tolerance of -00 -0.1 is assigned to the pin diameter. To find out the location accuracy in translation with the help of the given values in the problem, so these are the values already given in the problem. So with the help of the given values, we have to find the location accuracy in translation and location accuracy in rotation. Now the spigot and recess are assigned with 150 H7 tolerance. So if you find the tolerance value for the 150 H7, it is found to be +000 +0.4. Similarly, for the spigot and the component, the tolerance is -0 and -0.4. So this is the upper limit 150, the lower limit is 149.96. Similarly, for the recess on the fixture, the lower limit is 150, upper limit is 150.04. So with the help of the tolerances that we have found out from the data book, we can find the maximum clearance. So the maximum clearance results when you assemble a maximum hole with a minimum shaft. So the maximum hole size is 150.04 and the minimum shaft size is 149.96. So the maximum clearance comes to 0.08. The minimum clearance is resulting by assembling a minimum hole with a maximum shaft. So the minimum hole size is 150, the maximum shaft size is 150. Okay, looking by the tolerance values. So the minimum hole size is 150, the maximum shaft size is again 150. So when you assemble a minimum hole with a maximum shaft, the resulting clearance is 0. So the mean clearance is 0.08 plus 0 by 2, you are getting 0.04. From the 0.04, the upper value of 0.08 is varying by plus 0.04. From the 0.04, the lower value of 0 is varying by minus 0.4. So the variation about the mean clearance is plus or minus 0.4. So from these two values, okay, we can write the location accuracy in translation as 0.04 plus or minus 0.4. So when you choose a fit of dia 150H7 and dia 150H7 for the spigot and recess, the location accuracy is found to be 0.04 plus or minus 0.4. If you are not satisfied with the arrived value of 0.04 plus or minus 0.4, the tolerance, okay, should be further reduced. So instead of going for H7, we have to choose a tolerance of 150H6 and H6. So that be this location accuracy can be further improved. Now let us see how to find the location accuracy in rotation. When the component is assembled or loaded onto the fixture, this pin is trying to arrest the rotation of the component with respect to the fixture. But since a clearance fit is chosen between this diameter of the pin and this diameter of the hole, the rotation about the vertical axis is not fully constrained. So that calls for location inaccuracy in rotation. So before finding the location accuracy in rotation, first we have to find the pin diameter P. So the dia P value we have to find out using this formula. So the maximum diameter of the datum pin, dia P, is equal to MMC size of the datum hole. So where is the datum hole? So this is the datum hole. So the datum hole is having a size of 15H8. So if you look at the tolerance for 15H8, you will get the lower limit and upper limit. So we have to find the MMC size of the datum hole minus position tolerance of datum hole plus position tolerance of datum pin fixing hole plus position tolerance of datum pin plus working clearance. So using this formula, we can find the maximum diameter of the pin dia P. The MMC size of the datum hole, let us see how to find. The datum hole is assigned with a tolerance of 15H8. So it is having a size ranging from 15 and 15.027. So the MMC size of the hole is 15 mm. So that 15 is written here minus position tolerance of the datum hole. Now this is the datum hole on the component. The position tolerance of the datum hole is 0.05. Similarly, the position tolerance of the datum pin fixing hole. This is the pin, this is the hole over which the datum pin is fixed. This pin is fixed over to this hole. So the position tolerance of this datum pin fixing hole is 0.02, and the eccentricity between the two diameter of the pin is controlled using a position tolerance of 0.005. So all these three values are written here. So 15 minus 0.05 plus 0.2 plus 0.05 plus working clearance for this problem is not given, so it can be taken as 0. So when you work out the answer, the maximum diameter of the pin is arrived at 14.925. So once the maximum diameter of the pin is found out, then we can find the maximum angular play that is expected due to the various tolerances assigned to the parts of the assembly. So the maximum angular play is equal to tan inverse of maximum play between spigot and recess plus maximum play between datum pin and datum hole divided by the distance between spigot and datum hole. So let us assign the values from the drawing. The maximum play between the spigot and recess is expected when you have the maximum size of the hole minus the minimum size of the shaft. So the maximum size of the recess is 150.04. So that has been found out. So now this is the size of the recess. 152.04 is the maximum size. The minimum size of the spigot is 149.96. So these two values are substituted here. So the maximum play is expected when you have biggest hole assembling with smallest shaft. So 150.04 minus 149.96 is the value of maximum clearance between the spigot and recess, plus the maximum play between the datum pin and the datum hole. So between the datum pin and datum hole, what is the maximum clearance expected? So when you have the biggest hole assembling with smallest shaft, you get the maximum clearance. So what is the biggest hole? So 150 H8 has a tolerance of plus 0.0 plus 0.7. So the maximum size of the hole is 15.027. Similarly, the dia P has been found from the formula as 14.925, and the diameter P is given a tolerance of minus 0.0 minus 0.1 as shown in this figure. So the dia P is assigned with a tolerance of minus 0.0 minus 0.1. So the pin diameter is 14.925 minus 0 minus 0.1. So from this, the maximum diameter is 14.925, the minimum diameter is 14.915. So I can find the maximum clearance by subtracting the minimum diameter of the pin 14.915 from the maximum diameter of the datum hole 15.027 divided by the distance between the spigot and hole. So we have to substitute the distance between the spigot center and the hole center. Since the PCD is 110, half of the PCD is 55. So the distance between this axis and this axis is half of the 110, that is equal to 55. So the 55 is substituted here, and the value comes to tan inverse of 0.00349. So the angular play is found to be 0.2 degrees. The mean angular play is found to be half of the maximum angular play. So 0.2 by 2, you are getting the mean angular play as 0.1 degree. So this mean angular play is nothing but the location accuracy in rotation. So the location accuracy in rotation is found to be 0.1 degree. When you convert this into minutes, you have to multiply with the 60 to convert the degree into minutes. You are getting 6 minutes of a degree. So for this problem, the location accuracy in rotation is 6 minutes of a degree, and the location accuracy in translation is already found to be 0.04 plus or minus 0.4.